I left the SOHCAHTOA up there because I think that can be a very helpful thing to you. Remember, you are responsible for knowing everything on that orange sheet. So, start working on it. All right, so here we go. We're doing sine, cosine, tangent, cosecant, secant, and cotangent. And there is no picture drawn. So remember, when there's no picture drawn, we're going to set up our coordinate axis system, and we're going to set up a right triangle in quadrant 1 of the coordinate plane in order to put theta in the origin. Please get in the habit of drawing that picture, unless they give you a picture. Use theirs if they give you one. But if there's no picture, then that's what you're gonna do. Now, what do we know? We know cosine is root 5 over 3. Radicals are part, they're all the time. You're gonna have them all the time. So don't be uncomfortable with them. Root 5 over 3. What does that mean about secant? It's 3 over root 5, or 3 root 5 over 5. What about all the rest of them now? What am I going to do? Who remembers? Uh-oh. What's cosine? What's the definition of cosine? Adjacent over the hypotenuse. So in this picture, this is hypotenuse, this is adjacent, remember there's theta, and this is opposite. So can't I mark this side root 5 and this side 3? Now this happened to us yesterday. We're missing something. How are we going to find that missing side right there? Josh?
A squared plus b squared is c squared.
So a squared plus b squared equals c squared, which is called the Pythagorean theorem. And c is always the hypotenuse. So that's going to be 9. 3 squared. Now no one cares what a and b are. Root 5 squared. What's square root of 5 squared? 5. So it looks like, what's that missing side going to be?
4.
No, not 4.
2.
2. Remember, everything's squared in the Pythagorean theorem. So when you put it in your picture, you have to square root it. So use 2. And here we go. What then is my sine?
Opposite over
Which would be 2/3. And the cosecant then is 3/2. And then what's my tangent? 2 over root 5, or 2 root 5 over 5. And then my cotangent is root 5 over 2. Easy peasy. All right, one more. Just like that. So I'm going to draw my picture. Make sure you're drawing a picture that looks just like that. It's going to be critical during this chapter. And what do I know? They're going to tell me something. They tell me that the cosecant is root 17 over 4. So, let's label the sides of our triangle. I know this is hypotenuse. What's this? What's this right here? That's adjacent. And this is opposite. Now, this time they gave me the cosecant. What's cosecant? I heard somebody say it, hypotenuse over opposite, because it's the flip of the sign. So hypotenuse is root 17 and opposite is 4. Now I'm missing my adjacent. How am I going to find it? Pythagorean theorem. So, a squared plus b squared equals c squared. And this is the hypotenuse. So what's the square root of 17 squared? 17. Remember, when you take the square root, they cancel. 16 plus b squared. 4 squared plus b squared is 17. So, oh, what's that going to be? Yep, it's just going to be 1. Okay, you need to be able to do that by yourselves. Everybody following along, okay? So now I can do my rest of my things. So adjacent, cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And there we go. Alrighty. Easy. Now we're going to switch gears a little bit. So last chance, I'm going to erase all this stuff. Anybody have a question about this? Okay. Now, we are going to evaluate without a calculator the sine of pi over 6. All right, I want you to think back to December. 16, I got you back behind Ava. You all right back there?
Yeah.
Okay. Does anybody remember anything about pi over 6? That's a radian measure. How many degrees is pi? 180. So what would pi over 6 be? 180 divided by 6, which is 30. So this is really saying to me, find the sine of 30 degrees. Okay, so again, pi is 180, pi radians is 180 degrees. So 180 divided by 6 is 30. Okay? Now, I want you to draw this same picture that we drew in our last couple examples. Remember, when we have to draw a picture and they don't give us one, that's the picture we're going to draw. in our earlier examples, we didn't know what our angle was, we called it theta, and we put it right there. Well, this time I know my angle. My angle is 30, so I'm gonna put it right there at the origin. Whatever my angle is, it's gonna go at the origin. And this time, that angle is a 30. Okay? Now, I need sine. Sine is opposite over hypotenuse. I do not know what these lengths are. Or do I? What kind of a triangle is this? That's a 30, that's a 90, and this is a 60. This is a 30, 60, 90 triangle. So on your orange sheet, you were asked to memorize the sides of a 30, 60, 90. They never change. They never change. The sides, if your triangle is 30, 60, 90, the ratios will always be the same. Across from the 30, across from the 30 will be 1. Every time. Across from the 60 will be root 3, and your hypotenuse will be 2. Kids, that never changes.
Is that X? Or what do we consider
No.
that?
No, those are just numbers.
Okay.
No X's, just numbers. So when you are labeling the sides of your 30, 60, 90, across, wherever the 30 is, here, now it's here, but across from the 30 will always be 1, across from the 60 will be root 3, and the hypotenuse will always be 2. Now, it's an easy problem then. Sine is opposite of the hypotenuse. What's the sine of 30 degrees? 1 over 2. That easy. I'm gonna skip down and do C. What's pi over 3? 60. How do we know that? 180 divided by 3, yep. Yep. So I'm going to draw my picture, same one I always draw. And this time my angle is going to be 60, because that's the angle in the problem. And since that's a 60 and that's a 90, isn't this a 30? Don't I have another 30, 60, 90 triangle? Now it's oriented a little differently, but it doesn't matter. Across from the 30 is 1. Across from the 60 is root 3, and the hypotenuse is 2. Never changes. Now, keep in mind your angle's here at the origin. So this is the adjacent side. This is the opposite side. And this is the hypotenuse. Now, we want the secant. What is secant? Reciprocal of cosine? And cosine is adjacent over hypotenuse. So what's secant? Hypotenuse over adjacent. So hypotenuse hypotenuse over adjacent. Did you get 2 as your answer? So easy. D. We're gonna come back and do D in a minute, it's a little bit different. We're gonna do D. D says find the cotangent of what? What's pi over 6? 30. So I draw my picture. Is that another 30, 60, 90 triangle? Yep. Across from the 30 is 1. Hypotenuse is 2. Across from the 60 is root 3. This is hypotenuse. Opposite. Cotangent. What is cotangent? Adjacent over opposite. So adjacent over opposite would be root 3 over 1, or just plain old root 3. When we're doing these problems by hand, we're finding what we call the exact value. If you typed this problem in on your calculator, it would give you a decimal, but it wouldn't be exact. This is the exact value. Anytime the directions say anything about exact values, you're to do it by hand. We can't do every problem by hand, but we can do a problem that's a 30, 60, 90 by hand. All right, what's different about B? Tangent pi over 4. What's different about that one? What's pi over 4? What'd you say, Jared?
45.
45. Now, that doesn't change anything, that doesn't change anything about how we draw it. The difference is, what kind of a triangle is that? 45, 45, 90. And so my ratios are different than a 30, 60, 90. For a 45, 45, 90 triangle, the sides are 1, 1, root 2. So across from the 45s are 1s, and the hypotenuse is root 2. It's called an isosceles right triangle. Alright, I want the tangent. What is tangent? Opposite over adjacent. And so what's the tangent of 45? 1. 1 over 1. 1. Alright, I want you to try E and F on your own with your partner. See how far you can get with these two problems. All right, did you get the first one done? Did you get E done? Did you get root 2? Or root 2 over 1? Got it? Okay. Now, pi over 3, this one is a 60. So at a 30, 60, 90, across from the 60 is root 3. Hypotenuse is 2. Across from the 30 is 1. What happens if you don't memorize all this stuff, guys? You will fail. Yep, because everything is based on this basic memorization. It's really easy once you get it memorized, but you've got to have it memorized. So I want cosine. Cosine is adjacent over hypotenuse. That would be 1/2. Yep. 1/2. Now, because we're using 30, 60, 90, 45, 45, 90 triangles, are we going to be using these same numbers over and over and over again? Yes. Yes. So you're going to get lots of answers that are root 3s, or root 2s, or 1/2s. All right, perfect. Now we're going to practice a little bit on our calculator. So get your calculator out. Not messing with this semester. Talk to Mr. Freaky. No calculator means an infraction. And after a certain number of infractions, you're out. Get a calculator. Put batteries in it, and let's go. I want you to look carefully at these problems, the whole string of them, and I want you to tell me some things you notice. Do you notice anything about these problems?
None of them are 45 through.
Okay. Yeah, that's a great observation, Wyatt. They're not 45s, 60s, 30s, which means I can't do it by hand. That's why I'm using my calculator. I can do my special angles by hand. 30, 60, 90, 45, 45, 90. Everything else I need a calculator for. All right, do you notice anything else different about them? Well, what's different about this angle and this angle? That's 10 degrees. This is pi over 9 radians. This is a radian measure. So I'm going to mark this with an R. That's a radian. Do you see any other radians up here? This one's a radian. Any radians over here? Actually, there is one. It's right here. How do I know that's a radian measure? Because it doesn't have a degree mark. If it doesn't have a degree, then it's a radian. Does it have to have a pi? Nope. Usually they do, but they don't have to. So these guys are all radians. So I'm going to put them on hold for a minute, and I'm going to do the degree problems first. So I'm going to turn my calculator on, and I'm going to go to mode. And I'm going to make sure that degrees is highlighted. Okay, so go to mode. Press mode. and then see one of your options is degrees there, highlight that. So click over to it, press enter. So that's highlighted. Now we are in degree mode, which is exactly where we need to be if we're gonna be typing these things in on our calculator. Now, guess what? When I go to do these ones that I marked with an R, I'll go back to mode and I'll change myself into radian mode. So I have to pay attention whether my angles are degrees or radians. And I'm gonna do all the degree problems so that I don't have to be flip-flopping back and forth. All right, everybody in degrees?
Do we click enter once we're over it?
Yep. Now I'm gonna press secant. Oh crap. What about pressing secant? Don't have it. Paid all this money for this calculator, and it doesn't even have a secant button. What do I know about secant? What is secant definition-wise? It's reciprocal of cosine. So when we type this into our calculator, we will literally type 1 divided by cosine 10. 1 divided by cosine 10. And you should get, doesn't tell me how to round, you should get 1.0154. Is that what you got? How do we put a secant into our calculator? 1 divided by cosine. You gotta memorize your orange sheet, because you gotta memorize that secant is the reciprocal of cosine. All right, let's come down here. Oh, thank goodness, I have a tangent button. So I'm gonna press tangent, and then 28. Now, we practiced this before Christmas. I need a degree mark. So I go to second angle, degree, and then 11, second angle, minute. And you should get 0.5358. All right, who got 0.5358? Okay, keep your hand up in the air. If you didn't get that, go find one of those people. I've already taught you how to do this. I'm sorry you forgot. Go find somebody. All right, you were the heaven man.
I did. 28. And then 11. Close the parentheses. Second. And the minutes. For that one?
Ooh, this picture is nice.
And then what am I gonna do? Your side. Right, parentheses. The Philippines is crazy. What? No, yeah, that's a good difference. I would not say after. I'm not going to change it.
Bro.
Oh,
You gotta
yeah,
put it
that
away.
way.
All right, let's come back together. Here we go.
Yeah, there you
Here we go.
That is great.
Guys, can't reteach everything. You have to remember something. You have to take your notes and you have to study. Okay? Got a lot to learn. All right. Okay. That was all right. So now I'm ready for this one. Time out. I do not have a cotangent button. So how do you think I'm gonna put a cotangent into my calculator?
Second.
Nope.
1 divided
1 divided
by 10.
by tangent. Very good, Daryl. 1 divided by tangent. Because isn't cotangent the reciprocal of the tangent? and reciprocal means 1 over. So you physically type, there's no shortcut buttons. You type 1 divided by tangent, 13 second angle degrees, 19 second angle minutes. And you should get 4.2248.
You don't, yeah.
All right, now we're ready for this next one. This is when things get wild and wacky. Good news is, it's a sign, and I have a sign button. I'm just gonna press sign. 147 second angle degrees, 18 second angle minutes, and then where do I get that seconds button? This is called seconds. Where do I get that? Who remembers? Alpha plus. Yep, you gotta press alpha plus to get your seconds mark. And that is 0.7954. Yep, we already did it all. Not reteaching. All right, now I've done another cotangent. So once again, since it's not a button I have to do some finagling. So this will be 1 divided by tangent. Now, I don't want anybody to be alarmed. Did you get a negative?
Yeah.
That's okay. Half your trig values are gonna be negative. Get used to it. It's perfectly okay. I can understand why you're wondering. We'll learn it. We'll figure it out. But right now, trust the calculator. That's your answer. And then I think there's just one more degree. Tangent, 318. Who got this one?
Negative.
Negative 1.7112.
413. 29. So that would be 3. Perfect. Beautiful. So we have now done all of the degree problems. Okay? Now, typing in a radian problem is no different. We're going to type the same stuff, same kind of stuff, but we have to be in radian mode. Okay? So going back to this one, cosine pi over 9. So I'm going to go to mode. I'm going to go down and highlight radian. Now every angle I put into my calculator will be entered as a radian now. Okay? So here we go. I'm going to type cosine because I have that button. Now find your pi button. It's right under clear for me. Pi is over here. Press second caret button. That's your pi. Divided by 9. Physically type in the pi button. So cosine pi over 9. What'd you come up with? 9397.
Would we get the same answer if we put 180?
No. Because as soon as you put 180 in, then you're back in degrees.
But
Okay, Jack got the wrong answer.
I got the wrong answer too. I got 0.9998.
Okay, because you didn't change your calculator
Oh, it's a radian.
into radians.
Close.
This is going to happen over and over again, guys. You have got to stay awake and alert. If you're putting in a radian measure, your calculator must be in radians. All right, let's see. Now I've got this one, cosecant. I do not have a cosecant button. What am I gonna have to type in? 1 over sine. Alright, so literally type 1 divided by sine 5 second pi divided by 16. So 1 divided by sine 5 second pi divided by 16. And you should get what? What did you come up with? 1.2027? Alright, I got a real mess here. Where am I at? Here? This one's easy. It's a cosecant though, so how am I gonna have to type it in? 1 divided by sine 2. So 1 divided by sine 2. What'd you get? 1.0998. And last one. How am I typing it in? 1 over cosine. 18 pi over 23. So 1 divided by cosine. 18 second pi divided by 23. You do not need any parentheses. Your calculator will take care of all of that for you. I got negative 1.2891. Is that what you got? Perfect. All right, put the calculator down now. We're gonna do a little work without it, and then we'll go back to it. Kind of go back and forth. Now this is kind of backwards of what we did a little while ago. I don't know. I don't know what theta is. There's my picture. But I know that its cosine is 1/2. What does that mean in terms of the triangle? If the cosine is 1/2. Well, it means the adjacent side is 1 and the hypotenuse is 2. Think. We have a 1 and a 2. What's that? √3. Kids, you've got to recognize this is a no calculator problem. And don't we have a special right triangle whose sides are, 2 of them are 1 and 2? And the other one then is root 3. Now your job is to figure out how big that angle is. Okay? So we have a 1, a root 3, and a 2. Anybody want to take a guess what that angle is? If you said 60, you are perfect. 60 degrees. Why? Because it's across from the root 3. And the angle that's across from the root 3 is 60. Beautiful. How about this one? This one's hard. This one I'm going to redo for you. Now, would you agree that if I had 1 over root 2, when I rationalize that, I would get root 2 over 2? Right? This one's a little tricky. I won't trick you on a test or something. This is the same as this. And it's easier to think about it like this in terms of the triangle. So here's my triangle. I don't know what that angle is. I'm trying to figure that out. But I know that the opposite side is 1 and the hypotenuse is root 2. Right? Now think about this for a minute, guys. What kind of triangle has one side that's 1 and another side that's root 2?
A 45 degree.
That's a 45 degree. So the answer to that question is 45 degrees. See how we're doing this backwards? You're doing great. Couple more there. All right, so cosecant is 2. What's cosecant? Reciprocal of sine. So cosecant would actually be hypotenuse over opposite, because it's the reciprocal of the sine. So in this triangle, wait, there's only one number there. Over 1. The hypotenuse is 2, and the opposite is 1. Okay, stop right now. What kind of triangle has a regular 1 and a regular 2?
60, 30.
30, 60, 90. Yep. And across from the 1 is the 30. So the answer to the question is 30 degrees. This would be root 3. Don't need it, but all right, see if you can figure out D. Tangent. Think about what your triangle would look like if the tangent is 1. What's tangent? Well, tangent is opposite over adjacent, so 1 over 1. So opposite and adjacent are ones. What kind of triangle has 1 and 1? 45 degrees. Hypotenuse would be root 2 if you needed it, but you don't. All right, 2 more, we're done for the day. Secant is 2 over root 3. Okay, now stop and think. What is secant? Reciprocal of cosine. So cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. So hypotenuse is 2 and adjacent is root 3. What kind of triangle do I have? 30, 60, 90. Now be careful. This angle is across from the blank side. Well, how big would the blank side be? If that's 2 and that's root 3, this has to be 1. What angle is across from the 1? 30 degrees. You have to pay attention to what is across from your angle. That's how you determine whether it's the 30 or the 60. Last one, cotangent equals root 3. What's cotangent? Reciprocal of tangent. Tangent is opposite over adjacent, so this is going to be adjacent over opposite. So my adjacent side is root 3 and my opposite side is 1. What kind of a triangle has a 1 and a radical root? A 30, 60, 90. And across from the 1 is which angle? 30. So the answer is 30 degrees. Good work, folks. Are we starting to get the idea? We got to get that orange sheet memorized? Yeah, figure it out.